Okay, today आज हम साउंड पढ़ने वाले. Okay, so we will be studying the scientific notations and scientific concept behind sound. So we all know what sound is. ठीक है, हम सबको sound in general समझ आता है. But let's precisely understand कि scientifically वो क्या होता है. So let's just first start with the definition of sound. Sound. So let's see. One of the meanings that we know about is sound refers to auditory sensation which ceases when the sound sensing organ, which is generally ear, especially in humans, is withdrawn.
सर which के बाद क्या लिखते
Yeah,
हैं सर which सी है
ceases, is withdrawn from the scene. So Pradeep gives us a definition of sound that we know, general definition, not so general, but yeah. So according to Pradeep is what this book, not some person. So according to this book, it refers to the auditory sensation. Auditory sensation means sensation of hearing. So हमें hearing की sensation जब होती है तो sound हम बोलते हैं उस चीज को जिससे हमें hearing की sensation होती है जब वो sensation हमारे organs तक reach करती है, and अगर हमारे organs तक वो नहीं आएगी तो we say कि sound is not there. Okay, for example, if you are at the last seat and I whisper something, if you cannot hear me, you say that it is like it does not sound for you because you did not hear it, it did not reach your ears. But what we will be studying as scientific definition of sound, or the real meaning of sound is a mechanical energy. Sound is mechanical energy which produces sensation of hearing. So according to this definition, whenever I'm speaking, basically my mouth is producing some form of energy. That is a mechanical energy, form of a mechanical energy. And when it reaches your ears, that energy is converted, okay, into electrical signals. That's why you can hear me. Now, according to this definition, even if you do not hear me, this does not mean sound is not produced, because I will still produce some energy. But if that energy is dissipated until and unless it reaches you and it is basically lost to the environment जब तक वो आप तक पहुंचती है, meaning कि produce तो हुई थी sound लेकिन आप तक पहुंची नहीं. Right? For example, अभी room 3 में भी class चल रही है, वहां भी कोई ना कोई टीचर कुछ ना कुछ बोल रहा होगा, लेकिन we cannot hear that because that sound is not reaching our ears. But is sound produced there? Yes, it is produced. So according to this definition, which is the definition, scientific definition of it, it is a form of mechanical energy and it produces the sensation of hearing. So next time anyone asks you what sound is, this should be your answer. बोलो.
फिर जब तक साउंड में लाइक जब तक हमने हेयर ही नहीं करी साउंड तो हम कैसे बोल सकते हैं साउंड प्रोड्यूस की.
Let's think about it. So जब तक sound, like this is a very common misconception कि हम sound produce होगी नहीं होगी हमें पता कैसे चलेगा अगर हमने सुनी नहीं. ठीक है. Now think of it. You're watching TV. ठीक है. You just mute the TV and then there is some blast scene going on in the TV. Do you know that there is sound produced? Like if you see a blast, you know there is a high amplitude sound produced. So just because you know there would be sound produced, you don't really need to hear the sound. You just need to know कि क्या वहां पे energy थी. हाँ थी तो sound produce होगी. Even though you have muted the TV, this does not mean कि अब sound produce ही नहीं हो रही वहां. This simply means it's not reaching you. Right? And anyways, to use a different example, if you see lightning, You know sound will be eventually तुम तक आएगी sound. Obviously speed of light is faster than speed of sound. तो lightning पहले दिखती है and then sound आती है आपको. लेकिन still, the moment you see lightning, you know that a sound is being followed by it. So even if you put on headphones and you could not hear that thunder, but you still know that there was thunder, right? So that is the meaning of sound.
Sir,
Yes.
sir, simply energy भी लिखेंगे sound and energy with
The thing is, you have to be precise. Energy तो बहुत चीजें होती हैं. Heat with your energy, लेकिन heat does not produce sound. So that's why we need to specifically say that it is mechanical energy.
mechanical को हटा दे तो
Sound is a form of energy that produces sensation of hearing. Now, well, yeah, that is possible that you could skip that. But still, next, let's discuss propagation of sound. So, propagation of sound. Propagation मतलब पता है आप लोगों को?
yes sir
Yes, sir. Yes, sir.
How it is transmitted. मतलब how does it travel? Means does it need a medium? Does it not need a medium? That is the things that we'll be concerned about in propagation of sound. So let's see. Let's understand when is sound created. So the sound created by the source reaches the listener through the particles of the medium without any transport of the medium. Basically, it travels through disturbances. Okay. Now, this disturbance that carries sound is called sound wave. And इसका जो motion होता है उसे हम बोलते हैं wave motion. The motion of this wave is known as, ठीक है, wave motion. तुमने wave motion पढ़ा है?
नहीं, sir.
नहीं? Wave motion पढ़ा है.
तो स्कूल में सर ने बताया था.
So let's see what happens when sound is produced. So let's say we have a speaker. Okay. Now we have a medium. Medium has particles. So a lot of particles. Now, when sound is produced, there is an energy transfer from particle to particle. So one particle creating compressions and decompression, जो हम थोड़ी देर में देखेंगे. So this movement results in the sensation of hearing on this end. So if a person is standing here, he can hear the sound through the movement of particles. Now this does not mean actually medium move कर रहा है. It's just there are disturbances in the medium and those disturbances are called sound waves. ठीक है? जो मोशन साउंड वेव फॉलो करते हैं उस मोशन को हम वेव मोशन बोलते हैं. Now wave motion has a complicated definition but a simple meaning. So let's just write the definition of wave motion first and then we'll try to understand. Wave motion is a form of disturbance which is due to repeated vibrations of particles of the medium about their mean positions and the motion is handed over or transferred from one particle to other without any net transport of the medium. So note this down, then we'll understand this. चलो समझते हैं. So let's say, let's take a simple example through a rod. So अगर एक rod rest पे है, this is called its mean position. मतलब constantly इस पे. अगर ये move करता है, ठीक है, मान लो इसे हम right push करते हैं, ठीक है, इसे right push करते हैं हम, ये right जाता है, dotted line represent करते हैं, right के, and then फिर वापस ये left में जाने लगता है, and so on and so forth, जब तक ये वापस अपनी rest के state पे नहीं आ जाता, ठीक है, somewhat like this. This type of motion is called vibration in simple sense. कि वो right left right left right left right left right left right left ऐसे आके एक पॉइंट से मूव करते हैं, सेम मीन पोजीशन पे आ गया. सो बेसिकली वो बार बार अपनी मीन पोजीशन पे आ रहा है, लेफ्ट जा रहा है राइट जा रहा है, मीन पोजीशन पे आ रहा है, बार बार सेम जगह पे आ रहा है. दिस टाइप ऑफ मोशन इज फॉलोड बाय द पार्टिकल्स दैट ट्रांसफर मोशन और ट्रांसफर साउंड. ठीक है, तो होता क्या है कि जो एक्चुअल पार्टिकल्स है, लेट्स से दिस इज वन पार्टिकल, दिस इज सेकंड पार्टिकल, दिस इज थर्ड, दिस इज फोर्थ, जस्ट फॉर अ सिंपल एग्जांपल, एंड ये सोर्स है. सोर्स मींस प्रोडक्शन ऑफ साउंड, साउंड सोर्स. क्या अरे ले यार, क्या बनाओ तेरे लिए? Let's make a Bopu type speaker. So it's somewhat like this, है ना? है ना? So sound source, and then this is the, like, let's say ear. So ear यहाँ पे. So what's happening is जब sound produce होती है, so this particle start vibrating. ये vibrate करने लगता है, and then ये vibration transfer करता है next particle को. Then ये vibration transfer करता है next particle को. Then ये vibration करता है next particle को, and then we can finally hear it. Now this type of motion does not result in this particle moving altogether. मतलब जो पहला पार्टिकल था वो अपनी जगह पे ही रहा, वो मूव नहीं करा, बट इट जस्ट ट्रांसफर्ड द वाइब्रेशंस ओवर टाइम. सो लॉट ऑफ पीपल माइट थिंक कि जब एनर्जी प्रोड्यूस हुई है, फॉर एग्जांपल एक्चुअल जब फोर्स हम लगाते हैं किसी चीज पे, जब हम मैकेनिकल फोर्स लगाते हैं किसी ऑब्जेक्ट को पुश करते हैं, या फिर मान लो यू आर ब्लोइंग. सो लेट्स से वी हैव समवन्स आर, इसका माउथ है यहाँ पे, ठीक है, लेट्स मेक हिज माउथ हियर. एक दांत तोड़ दे, ठीक है. So this is your mouth, okay. आप यहाँ पे ब्लो करते हो हवा, ठीक है. Then you expect the particles to actually move, है ना? Particles क्या होंगे? Actually move करेंगे. So this is actual movement, but sound does not create actual movement. वो अपनी जगह पे ही है, बस वो सेम जगह पे वाइब्रेट कर रहा है. So it's the difference. You need to understand the particles are not actually moving, they are just vibrating and then transferring that vibrations over time to other particles. And what's important here is these vibrations that are transferring are there because they are particles. अगर particles ही नहीं होंगे तो vibrations किसके बीच में transfer होंगी? Nothing. That's why sound needs a medium to travel.
And the medium.
And different types of medium will propagate sound differently. ठीक है? अच्छा.
Sir, please.
R is mouth.
Sir,
बोल.
हाँ सर, मतलब जितना ज्यादा डिस्टेंस रहेगा तो उतना ही ज्यादा वाइब्रेशंस पास होगी.
So now it's very logical कि हर बार जब vibration transfer होगी, so there would be some energy lost to the environment. So over time, the more the distance, the lesser would be the sound energy reaching there. ठीक है? So अगर यहाँ पे है and then compared to that, अगर कोई part यहाँ पे अगर हम सुनने की कोशिश करें, so there would be a difference in what we'll be studying about is difference in amplitude of sound that we'll be studying. So वहाँ पे faint sound आएगी and यहाँ पे ज़्यादा sound आएगी. Like if you are closer in a concert, when you are closer to the speaker, you even feel the music sometimes. And then if you are further back, then आपको sound comparatively बहुत कम सुनाई देती है. ठीक है? By the way, never stand right in front of a speaker in a concert or something. कान खराब हो जाएंगे, pretty sure. So do not do that. Headphone लगा के खड़े हो जाना. Actually, the thing is you'll feel the bass, but your ears would not. So good for you. If at all you go to a concert. Okay. ये diagram जरूर बना लेना. It's good for you.
सर आज इसका मॉडल भी.
Yes, you can make if you want. इसके बाद में wave की definition लिखाता हूँ आप लोगों को. Wave motion. Oh sorry, लिखवा चुका हूँ. उसके बाद ये लिख लो तो बताना. So इसी like explanation से we can totally understand that a material medium is essential for the propagation of sound. इसके reasons क्या हो सकते हैं? इसके reasons है to produce sound we must supply energy for the vibration of the source comma for onward transmission we must provide a medium, material medium.
So normal medium और material medium.
The thing is sometimes vacuum को भी लोग medium बोलते हैं. ठीक है? So vacuum is not a material medium. It does not have anything. It's a medium in some sense, but it does not have any particles in it. So material medium means it should have some particles in it. Okay? So यहाँ पे कुछ words है जो आपको समझ आने चाहिए. To produce sound, we must supply energy. Obviously, we understand what energy is. Vibration we have understood. Onward transmission मतलब एक के बाद दूसरा. So onward transmission मतलब simply एक के बाद दूसरे तक जाने के लिए energy. You must need some medium that has some particles in it. The sound can also be said as the following. Sound is a form of energy which is emitted by a vibrating source and transmitted through a material medium, producing the sensation of hearing. So now that we know some terms, we can change a little bit of our definition to sound is a form of energy which is emitted by a vibrating source and transmitted through a material medium producing in us the sensation of hearing. Let's see a sound wave and try to understand its compressions and rarefractions. So, compressions and rarefractions.
सिर्फ movement है ना wave की.
Oscillation of particles or vibration of particles. So, have you ever seen this instrument? तुमने देखा होगा मे भी कभी साइंस एक्सपेरिमेंट में. So,
तेरे tuning को क्या है?
like bear with my drawing, but yeah, this is a tuning fork. So when you like strike it on something, या फिर like आप इसे क्या हाँ, so that it vibrates in such motion, right left and then बहुत तेज से करता है. Sometimes you can see it, sometimes you cannot, depending upon आप कितने ज्यादा बड़ा लेते हो. तो ज्यादा बड़े में देखना आसान होता है because it's not vibrating that fast. A thinner one would vibrate much faster and देखना कभी possible नहीं. So it will create some vibrations, it will move further. So it will create some area which will be compressed. Okay. And then some area which the air will be not compressed, I would say. So, and this will follow this pattern. So something like this. Okay. So ये जितने भी जगहें हैं यहाँ पे जो concentrated है, ये compressions है, ठीक है. And then जितनी भी खाली जगहें हैं उन्हें हम बोलते हैं rarefractions. Okay.
सर आर कैसे लगा
Yeah.
रेयर फ्रैक्शन से प्रॉब्लम
हाँ fraction. Oh मैंने sorry. FACTION. Okay. So yeah, let's just write the definition what they have given. So the layer or region of compressed air is called compression, and then the region or region of rarefied air is called a rarefaction. This thing will tell us something about the sound wave. That is, a sound wave can be considered as propagation of pressure or density variation in the medium. So sometimes when something travels faster than speed of sound, so you would have heard about supersonic jets. So when something travels faster than the speed of sound, and तो वो क्या करता है, वो अपने अराउंड लाइक उसके, अगर आप कभी भी आप कोई वीडियो वगैरह देखोगे किसी सुपरसोनिक जेट्स की, यू सी सम लाइनिंग अराउंड इट. दैट इज द हाँ,
जब रॉकेट भी लॉन्च होते हैं तो
रॉकेट में भी होता है, बट देन अगेन इट्स नॉट दैट विजिबल टू एक्चुअली सी इट. जेट्स में देखना ज्यादा आसान होता है. नाउ दिस वुड क्रिएट अ सोनिक बूम. इट्स काइंड ऑफ लाइक सडन स्प्लैश, लाइक जब कोई चीज साउंड की स्पीड रीच करती है, उसे क्रॉस करती है, देयर इज दिस फिनोमेना दैट हैपेंस, दैट इज सोनिक बूम. उतनी डिटेल्स में नहीं जाऊंगा कैसे होता है क्या होता है, बट दैट सोनिक बूम इज केपेबल ऑफ shattering glasses. So if a jet goes nearby our home, supersonic jet, then probably all of our glasses would be shattered, all of our windows would be shattered because of this sonic boom.
साउंड वेव की वजह से
That is because of sound waves. It's basically because of sound waves.
तो साउंड वेव्स इतनी पावरफुल है, मतलब क्या लास्ट में उनका इफेक्ट
Yeah, like now sound is a form of energy. Any form of energy, if you give it enough juice, it can be powerful enough. For examples, one of the very common example I've seen is गाड़ी में तुमने देखा है लोग बड़े बड़े स्पीकर लगा लेते हैं. Now the reason for there are two reasons. First, तो उन्हें ट्रैफिक नहीं सुनाई देगा. The second reason why you should not be doing that is if you place very big bass speakers on your car. होता क्या है, with time अगर आप उसे हाई वॉल्यूम पे सुनते हो, your windows are vibrating and आपके शीशे बाहर आ जाएंगे. एक्चुअली काफी बार टूट भी सकते हैं, ये भी चांसेस होते हैं डिपेंडिंग अपॉन हाउ स्ट्रॉन्ग आर द ग्लासेस. So in any car, if you use like subwoofers and stuff, then it is very dangerous for you because you can shatter your glasses. Yeah, they'll get weaker and weaker eventually, and और कुछ नहीं होगा तो the glasses do get blown outside through. तो glass बाहर आ जाता है. This is something, this is a terminology you might even hear sometimes. कि glass बाहर आ गए because of bass speakers. So sound is very powerful. Sound is actually very powerful.
sonic boom or conical
किसी इंसान को मार सकता है.
Yeah, it is possible. Like it's possible. Like if you are outside and then एक बहुत powerful speaker है आपके right left है, तो you can like actually like आपकी eardrums obviously फट सकते हैं within like a high.
our brain can go crazy.
Not exactly brain. अगर आपकी eardrums ही फटते हैं तो it is quite painful. So you would not like to experience that, and that's why it's recommended you should not be using like you should not be around very high sound. So there is a particular limitation of how much sound.
the
But
40
yeah.
decibels.
Yeah, 40, I don't think 40 decibels.
Sir, police
Yeah, that is something you should not be doing. But the thing is, how much can humans survive is much less. Okay, let's study about the types of waves and what types of wave is sound. बीच में बातें मत करा करो, क्लास से बाहर निकाल दूंगा. Types of wave. Longitudinal waves and transverse waves. Let's see what a longitudinal wave is. So, if this is the direction of propagation, okay, this is the direction of propagation. So, and the direction of oscillation. ठीक है. Now what is oscillation or vibration? अगर जिस डायरेक्शन में वेव जा रही है उसी डायरेक्शन में वेव क्या हो रही है, ऑसिलेट कर रही है, वाइब्रेट कर रही है, means it is vibrating in this particular direction only, then it means that this is a longitudinal wave, because the direction of propagation and direction of oscillation or vibration are parallel. Now in a transverse wave, on the other hand, the direction of propagation and the direction of motion are perpendicular. So it would be something like it is moving in this direction, but it is oscillating up and down. So this is a transverse wave. This is a longitudinal wave. Okay. So sound is a longitudinal wave because you know
ट्रांसवर्सल वेव का एग्जांपल हो सकता है ना टाइड्स वाटर वेव्स
yeah, you could say that. That is one way of thinking about it.
सर बिकॉज़
You can think about radio waves as transverse waves, and you can even think about light as transverse wave in some situations. X-rays, yeah, नहीं, light दोनों नहीं होते. Light is transverse wave. Light is light की wave optics and क्या बोलते हैं रे ऑप्टिक्स होती है बेसिकली मीनिंग लाइट पार्टिकल की तरह and wave की तरह बिहेव करता है लेकिन जिस वेव की तरह बिहेव करता है दैट इज ट्रांसवर्स वेव. क्या डाउट है बोलो.
perpendicularly oscillate करना तो फिर से वो atom particle को energy कैसे
क्या
अगर वो perpendicular
they are capable of traveling without medium. It's not through particle. Their transfer is not through particles. They are capable of independently moving. So they don't need a medium. Yeah. These types of waves do not need, like light radio waves do not need a medium to travel.
दोनों चले जाते
Yes.
सर वाटर वेव को भी छोड़ रहे हैं
Yeah, water is not a good example of it because water is not actually a wave. It is like a lot of particles you see around acting in that motion. This does not mean that is actually a wave. So it is depicting itself in that form, but on a particular level, it's not that. But the name can be suggested from it. Yeah, then again, so the sound is a type of longitudinal wave. Why is it a longitudinal wave? Because you remember there were compressions and decompressions, and they were oscillating parallel to the direction of propagation. Okay, so a sound wave is obviously longitudinal. Note this down, draw the proper diagrams. Let's study about the sound wave now. So, अच्छा अब जो मैं वेव बना रहा हूँ तो मैं ट्रांसवर्स जैसी लगेगी लेकिन इट इज नॉट एक्चुअली ट्रांसवर्स वेव. हाँ, हम साउंड का ग्राफ बनाने की कोशिश कर रहे हैं बस. या बेसिकली ट्राइंग टू ग्राफ द साउंड. सो दिस इज द क्या हाँ ये साउंड वेव है बट ये साउंड वेव क्यों है इवन दो इट इज लुकिंग लाइक अ ट्रांसवर्स वेव. द रीजन इट इज साउंड वेव बिकॉज हम इस एक्सिस पे अब this is the direction of propagation. But this time we are taking this to be time. तो ये axis हमारी time है. तो इस ये axis हमारी time है and this direction is our density. Yeah. अभी देखेंगे. Density या फिर pressure. So जिस टाइम पे हमारे पीक पे है साउंड वेव, ठीक है, उस टाइम पे क्या है तो हमारी डेंसिटी है यहाँ पे मैक्सिमम डेंसिटी है. जिस टाइम पे वो अपने लोएस्ट पॉइंट पे है इस टाइम पे हमारी मिनिमम डेंसिटी है. एंड जो मिडिल ग्राउंड है वो है हमारी एवरेज डेंसिटी. जो मीन पोजीशंस बोलते थे ना हम जैसे एवरेज डेंसिटी. ठीक है. So this point, this peak is also known as crest, and this point is also known as trough. ठीक है. It is like comparatively अगर मैं आपके लिए डायग्राम बना दूं जो हम इतनी देर से साउंड वेव को देख रहे थे उसका. So it is like this is the point of compression, and then this is the point of rarefaction. Then this is the point of compression again. Then this is the point of rarefaction. Then again we have a point of compression and rarefaction. तो ये हो रहा है ये जो हम वेव
साइकिल चलता है
हाँ जब तक हमारी ईयर्स तक नहीं पहुंच जाता. So this is what these different things mean. ठीक है.
सर ये ग्राफ छोटा भी होता रहेगा ना एक टाइम
हाँ मतलब एम्पलीट्यूड में छोटा होता जाएगा बट एनर्जी डिसएप्टेड होने की वजह से. लेकिन अभी तो हम रिप्रेजेंटेटिव बना रहे हैं. सो फ्रॉम वन रो टू नेक्स्ट रो this whole is wavelength represented by lambda. ठीक है. This duration is known as wavelength.
चलिए रिफ्रैक्शन का भी उधर कॉम्बिनेशन का
क्या? हाँ सेम ही होगा. Doesn't change.
सर वेवलेंथ चेंज होता है
क्या?
वेवलेंथ
Wavelength like change होती है मतलब सेम साउंड की. नहीं wavelength अपने आप चेंज कैसे होती? Different sounds will have different wavelengths.
सर एम्पलीट्यूड तो चेंज हो सकता है ये साउंड
पढ़ेंगे ये पढ़ेंगे.
बट वेवलेंथ नहीं चेंज होती वेवलेंथ यूनिवर्सल रहती है.
The thing is different sound की different wavelength. So it will be the same. The reason you मतलब like अगर मैं तेज बोलूँ आपको या धीरे बोलूँ, you recognize my voice because my voice has fixed frequency and wavelength. The only thing that's differing is the amplitude. So like that's why if I speak small, like धीरे बोलूँ मैं तेज बोलूँ, it sounds yeah.
सारा वेवलेंथ सेम रहेगी.
Wavelength same like मतलब not same is not the right word for it because I'm not saying कि मेरी voice में अपने जितने सारे जितनी सारी चीजें मैं बोल रहा हूँ. Some of them are higher pitch or some of them are lower pitch. So this does not mean they have the same wavelength. It just means that उन same words की wavelength same रहेगी.
ज्यादा डिफरेंस नहीं.
हाँ like उसमें कोई difference नहीं आएगा. That is the thing. It's like light के sense में हम कहें तो जो colors होती है colors की fixed frequency होती है and that frequency cannot change.
वाइट ही होता है.
Yes.
तो सर हर एक वेवलेंथ की यूनिक वेवलेंथ होती है.
क्या? हाँ क्या बोल रहे हो?
सर कलर्स की वेवलेंथ डिफरेंट.
नहीं डिफरेंट कलर्स की डिफरेंट वेवलेंथ होगी. सेम कलर की दो डिफरेंट वेवलेंथ नहीं हो सकती. दैट प्रोडक्ट. अब हम कंप्रेशन की डेफिनेशन लिखते हैं तो मोर टेक्निकल वन. सो पोर्शन ऑफ मीडियम a portion of the medium where a temporary reduction in volume and consequently an increase in density takes place when a sound wave passes through a medium. Passes through a medium is called compression or condensation. Also known as condensation. Rarefaction
केमिस्ट्री का नहीं हो
कंडेंसेशन तो है.
केमिस्ट्री में अलग होता है, यहाँ पे अलग है. साउंड में तुमने कभी कंडेंसर नहीं सुना साउंड में?
नहीं
मिलता है.
तो क्या होता है कंडेंसेशन?
कंडेंसर इज लाइक आप माइक पे प्लेस करते हो. एनीवे छोड़ो.
कोई और नाम नहीं है.
क्या
नाम भी सारे हैं.
राघव भी तो इतने सारे हैं. हमने कभी कंप्लेन करी?
सर कर दो.
नहीं बेटा. a portion
हिमाचल में तो इतनी बड़ी जगह.
तो हिमाचल का क्या कर सकते हैं?
छोटा सा.
A portion of medium where a temporary increase in volume and consequently a decrease in density takes place when a sound wave passes through the medium. Is called a rarefaction. Okay.
The